Before we begin, let's recall Euler's beautiful formula. It says that e to the I theta equals cosine theta plus I sine theta. On the unit circle, the point e to the I theta has real part cosine theta and imaginary part sine theta. This compact notation is the key to everything that follows. Before we dive into powers, let's understand multiplication. When we multiply two complex numbers, something beautiful happens geometrically. We multiply their magnitudes, scaling the vectors, and we add their angles, rotating them. The result is a new vector that represents both transformations. If we multiply a complex number by itself, we get its power. In the expression z to the n is the exponent, and the result is the nth power. Each time we multiply by z, we scale the magnitude and add the angle again. Watch how z squared, z cubed, and z to the fourth evolve from this simple rule. What about negative powers? We define them so that our usual exponent rules still work. For any non-zero complex number, z to the n times z to the negative n must equal 1. This means z to the negative n is the reciprocal. Geometrically, the magnitude is inverted, and the angle is reversed. Notice how z to the negative 1 points in the opposite angular direction. De Moivre's theorem is a powerful tool that connects complex numbers and trigonometry. It tells us how to raise a complex number in polar form to any integer power n. Geometrically, when we raise a complex number z to the power n, we raise its magnitude to the power n and multiply its angle by n. Now, what about the inverse? Finding the nth roots of a complex number. For any non-zero complex number, there are exactly n distinct nth roots. These roots are equally spaced around a circle in the complex plane. Because they are equally spaced, they form the vertices of a regular n-sided polygon. Let's finish with a quick quiz to check the big ideas. First question. If the magnitudes are 2 and 3, and the angles are 20 degrees and 40 degrees, what happens to the product? Pause and think. The magnitude becomes 6, and the angle becomes 60 degrees. Second question. If z has magnitude 2 and angle 30 degrees, then z cubed has magnitude 8 and angle 90 degrees. Powers raise the magnitude and multiply the angle. Final question. How many distinct cube roots does a non-zero complex number have? The answer is 3, and they are equally spaced on a circle, forming a regular triangle. So the big picture is this. Multiplication multiplies magnitudes and adds angles. Powers raise the magnitude and multiply the angle. And roots split into equally spaced solutions around a circle.